Yeah, okay, great. Hi guys, and welcome back to the week 3 challenge introduction. So this week we have another interesting project for us to work on. So this week we're going to be working on end-to-end insurance risk analysis and predictive modeling, where we'll dive into real-world insurance data from the past to uncover low risk segmentation and build a smart model to optimize premiums and to do some prediction for the future. So it's really interesting and highly practical. Uh, Without further ado, let's just go ahead and start. So I'm just going to start with the business objective, which is a scenario. So you can, like for this week's scenario, you're working at a company called Alpha Care Insurance Solutions, where you are the company is developing cutting-edge risk and predictive analysis in the area of car insurance planning and marketing in South Africa. And you have been recently hired as a data analysis team, as a marketing analysis engineer. And your first project is to analyze historical insurance claims data. And based on your analysis, you're going to be coming back with an optimized the marketing strategy and to discover the raw risk targets for which premiums could be reduced. Premium is just the amount they should pay. So if they are low risk, you can reduce the premium for them and have higher number of customers from that targets, right? And thereby creating the opportunity to attract new clients from that, of course, low risk targets. So to deliver this objective, you would need to brush up on your knowledge and perform analysis in the following areas. So first and foremost, you need to understand the insurance terminology. So we have actually included a link here that you can check in order to see the top 50 common insurance terms, such as premiums, total premiums, claims, and so on. And then you're going to be learning and performing A/B hypothesis testing, where you will need to read the benefits of A/B hypothesis testing and accept or reject the following null hypothesis. So in A/B testing, of course, you will have, you will also see this in the tutorials, but you will have like a hypothesis and two hypotheses. The one is the null hypothesis, which you are seeing here. So there is no difference across provenance is the null hypothesis, and like the other hypothesis going to be there is a difference. There is a risk difference across provenances and so on. So you will also see accept or reject this null hypothesis based on your statistical work. Of course, the other is there is no significant difference between zip codes. There is no significant margin or profit difference between zip codes. And of course, there is no difference, significant risk difference between women and men. And lastly, you will also do machine learning and statistical modeling for each zip code. You will fit a linear regression model that predicts the total claim. Also, you will also develop a machine learning models that will predict optimal value given. Like a set of features about the car to be insured, the set of feature about the owners, set of feature about the location of the owner, and other feature you will find relevant. And of course, you will also record exploratory power of the important features that will influence the model. So you will also do exploratory analysis where, so we will introduce you to model explainability, where you will use tools to see which feature has impacted the model the most to come up with a certain decision or outcome. So your final report should detail the methodology you used, present the findings from your analysis, and make recommendations to plan feature that could modify or enhance based on the test results. So your analysis and your report will help your company tailor their insurance product more effectively to meet customer needs and preferences. So This week's challenge will help you with your data engineering, predictive analysis, and learning engineering skills. And this is designed to improve your ability to manage complex data sets. Of course, it's a huge data set with a lot of features. So you will learn how to improve, like handle a large and complex data set, adapt to challenge, and think creatively. Skills are essential. These skills are essential in insurance analytics. So it will also help you understand how hypothesis testing and predictive analysis can be applied in insurance analysis, even in technical language. So engage as much as possible, as much tasks as possible. The volume of complexity of the tasks are designed to simulate pressures and deadlines that you would normally see in this field. So it's just try your best, and we are here to help as well. Okay, so when it comes to the data, we have provided you with 1 year above more than 1 year data, historical data, which you can find by following this link. And in that key link, you will have these structures. These are all the features that you will find in the data. So by the end of this week, you will learn, understand data provided, extracting insights. This is very interesting. By the way, I would like to highlight and underline that it's very interesting once you get to understand how like insurances work, what the features actually represent. You'll find very interesting insights and patterns. So you'll have to explore different techniques, different algorithms, different statistical distribution, different ways of sampling, and visualization technique to gain insight. So it's going to be very interesting. I can promise you that, but it's going to require some input from you guys. Understand the data structure and algorithm by used in EDA and machine learning pipelines, modular and object-oriented programming, and Python package building, statistical modeling analysis. We have to use different statistical models to predict and analyze outcomes of A/B testing. Apply techniques such as the regression, square test, the t-test, the u-test if needed, and other tests as well, as appropriate to the hypothesis being tested. Of course, we will have a session where we will go over these things as well, so don't worry about it. And of course, A/B testing, designing this A/B testing, so designing the null hypothesis and implementation is also thing you're going to be learning those as well. And turning that into actionable results. This includes determining the sample size, selecting the control and the test group, which group should I use as a control group, and which should I use as the testing group, and so on. And of course, one another new thing you will learn here is data versioning, which is super important, especially if you are going to be working in machine learning and data science fields. It's going to come in handy. And for the key dates, of course, we are currently having the challenge introduction, and the interim submission and the final submission are going to be on the same dates as usual. For the interim, we're going to be submitting it on Sunday, 8 p.m. UTC, and for the Tuesday, for the final, you will be submitting it on Tuesday, 8 p.m. UTC. So before we move on to the tasks, is everything clear, guys? Do you have any questions? Is the objective, or the main the scenario, is it clear? Or is there any questions from you guys? Okay, so no quick questions, guys. Okay, I think that we can move on to the next part, which is the tasks or deliveries. So of course, we're going to start with the GitHub, where you will create your repo, set up your Git and CI/CD pipeline. And secondly, you will also do project planning with EDA and stats, where you will develop a functional understanding of the data, assess its quality, and uncover patterns in risk and profitability. So here the tasks are data understanding by using EDA. Okay, was that a mistake? I'm gonna answer this one. So some questions that can guide you guys to do some EDAs. What is the overall loss ratio, where you can divide the total claim with the total premium to see the loss ratio for that portfolio, and how does it vary across provenance, vehicle type, and gender. What are the distribution of the key finance variables? Are there outliers in the total claims or customer value estimates that could skew our analysis? Are there temporal trends? Like did the claim frequency or severity change over like 1.5 year period? That would have another result. Sorry about that. Okay. So sorry about that, guys, for the noise. So I'm audible, right? Yes, can you hear me? Okay, sorry. Okay, so the KPIs for this task is going to be proactively self-learning, sharing reference, EDA technique to understand data, and discovering insights, demonstrating stats understanding by using suitable statistical distributions and thought to provide evidence and actionable insights gained. So by end of task one, the minimum mission set to do is, of course, to create the GitHub repo for this one, create at least one branch to work on the task, commit your work. Of course, we recommend that you commit at least 3 times per day with a very descriptive committing message instead of just saying commit or just something. It should be meaningful and reflect what has been done. And perform EDA on the data summarization, data quality assessment by like univariant and bivariant, or if needed, multivariant analysis, data comparison across, like a gender, across provenances, type of car, the maker of the car, the premium, and so on. Outlier detection, just to outline and handle outliers in the numerical data and visualizations. At least 3 productive and beautiful plots that capture key insights that we get. And for task 2, you're going to be working on DVC, which you would use to establish a reproducible and auditable data pipeline, which is a standard practical practice in a regulated industry. So you can see DVC as Git, but for data and machine learning models. So you have Git for code and DVC for data, tracking your data, and for tracking the models. So it has a lot of interesting features and a lot of use and pros. So we will also have a session where we will take a look at DVC. So in a financial like insurance, we must be able to reproduce an analysis or model results at any time for auditing. So also there are some regulatory compliance or debanking, and DVC will help us ensure our data inputs and models are rigorously version controlled on as our code. So for instance, of course, you will have a session, so I'm not going to go too deep into this, but if you need to roll back to a certain stage of the data, for instance, you may have used like the wrong data cleaning method, and you want to have the previous data, so it's going to help you roll back to the previous version, and you can continue. So it's very interesting and very applicable. So you'll definitely enjoy it. So this is just how you can set up your PVC. Of course, we will have a session on it as well, so don't worry about it. So the minimum required or essential to do is to merge your previous branch, create a new one for the DVC commit, or you work with a descriptive commit message, or start DVC, configure local remote storage. Of course, you can have remote storage, but if you can have local remote storage, it's enough as well. For now, add your data, commit the changes, and push. Okay, task 3 is just statistical validating or rejecting null hypothesis about risk drivers, which will form the basis of our new segmentation strategy. This will help us to pinpoint a different or the target segmentation with low risk, so that we can have a lower our premium for that. So this is very important. So we're going to be using A/B hypothesis testing, where for this analysis, risk will be quantified into two metrics. The first one is claim frequency, the property, the proportion of the policies with at least one claim. So that have taken out the insurance rates. And claim severity, just the amount of the claim given a claim occurred. So if there is a claim, how much was it? So just the average amount of this claim is going to be the claim severity. And of course, the margin is defined by total premium minus the total claim. So don't mistake this with the average, which is the total premium claim over the total premium. So we have seen this null hypothesis earlier. So you're going to be accepting or rejecting this null hypothesis based on your statistical work. So you will select the metrics, choose a KPI that you will ensure or that you will measure the impact of the feature being tested. Segment the data into two. A is going to be, or group A is going to be the control group, which is plans with the feature, and the B is plans with the feature. So which is a test group. So this exactly like the statistical testing, which you have seen, I think, in high school or in universities, where we learn statistics. So for features for more than two classes, you may need to select two categories to split the data into group A and group B, which you must, of course, ensure that the two groups are selected do not have significant statistical difference or anything other than the feature you are testing. And for statistical testing, you can use a lot of tests, of course. You can conduct appropriate tests like chi-square test, categorical data, or t-test, or z-test, u-test. So you have a lot of course, we will have a session where we will go over these things, but we will have a lot of methods too. Of course, it depends on the data. For example, for numerical, for categorical, you cannot use the same test. They will have their own different tests, which we will have a session on how to tackle them. So, of course, you will have to analyze the p-value from the statistical test. If the p-values, so of course, this is the value. Of course, we have chosen to go with 0.05 because it's ideal, but of course, you can have a different number if you think it are reasonable that this will not work. So for the significance level, so I'm referring to this one, okay? So 0.005. So we have chosen 0.05, but if you feel you should go higher or lower with the right amount of data, or like ideal, you can also change it. But if the p-value is less than 0.5, we will reject the null hypothesis. So this means it's noise, not the difference is not or significant, so we can drop the null hypothesis. But if the p-value is greater than or equal to 0.005, 0.05. So we should take the null hypothesis, which suggests that the features do not have a significant impact on the KPI. So it's just rejecting or accepting the null hypothesis. So depending on the null hypothesis, you will reject. So like the reason is, so here the null hypotheses are, so there is risk difference across provenances. So if you reject the null hypothesis, you are saying that there is a difference across, there is a difference in risk across different provenances. But if you accept the null hypothesis, or if you fail, of course, there's a terminology, fail to reject the null hypothesis. So if you fail to reject the null hypothesis, there you are saying that there is no risk difference in across the provenances. And then you will analyze and report on the outcomes provided by the evidence. So the minimum essential to do here are to merge the previous branch and create a new one, omit your work, select the metrics, data segment your data properly, perform statistical testing, analyze and report, and execution of the test. And of course, you will have to interpret and make a recommendation from your test. For each rejected or accepted hypothesis, you should provide a clear interpretation of the results in business terms. So rejected the null hypothesis of provenance because the p-value is less than significant value. Specifically for this provenance exhibited 15% higher loss ratio than the other provenances, and so on. So this is just an example of output or a business recommendation. Okay, before I move to the last two tasks, is there any questions? Is there anything that's not clear? Please ask. So is everything clear? Can we move to the next ones? If everything's clear, just show me a thumbs up and move. Sorry. So is everything clear? Okay, good. So for task 4, of course, so far we have done like statistical testing, which will help us to understand the risks and identify risks. So now we will do the prediction part, which is the second phase. So we will build and evaluate predictive models that form the core of a dynamics risk-based pricing system. So here we will have, for the modeling goal, we will have claim severity prediction or risk model for policies that have claim, build a model to predict the total claim amount. So how much claim amount is it going to be? This model will estimate the financial liability associated with the policy. So for this policy, from like it can predict for a given policy, it will predict like the estimate amount of total claim it will have. So for the target variable, it will be total claims, and for the variation variables, of course, for the metric, you can use RMSE, and penalize the large prediction errors and R squared. Of course, we will also show you how you can select that with testing. And of course, secondly, it's premium optimization, so pricing framework. So you will need to develop a machine learning model to predict an appropriate premium amount. A native approach is to predict the calculated premium per term. Well, this is also a feature in the data that we have provided, but a more sophisticated business-driven approach is required for you guys. So from the advanced task, you can see you can build a model to predict probability of a claim occurring in a binary classification problem. So it's going to be the risk-based premium can be conceptually framed as premium, or predict probability of claim multiplied by predicted probability severity, plus expense loading, and profit margin is going to be your premium. So premium is the amount that the client is going to pay for to the insurance company. So statistical modeling here, the tasks are data preparation. Of course, you need to handle anything data, feature engineering, encoding categorical, of course, since for the machine learning to learn it should be in a numerical format. So you can use different encoding methods. One with encoding and label encoding are the most famous to convert the categorical data into numerical data. And then you will split the data into testing, training, and validating uh, with your percentage. Of course, you can use 70, 38, 20, 60, 40, but you will need to write about your decision. So we have, like I have chosen to go with the 70, 30 because of blah, blah, blah. And so on. And then you will choose the modeling technique. Of course, you will have to do it with linear regression, decision tree, random forest, and XBoost, like XGBoost. And you will build the model and you will evaluate that model by using different matrices, and you will extract the most, like you will do feature importance analysis, where you will analyze which feature are most influential in claiming premium. So after the model evaluation, you will see which model performs the highest by using different techniques or by reading the evaluations. And of course, you will need to see the feature importance. So by the feature importance, what we mean is, so for instance, let's say you're building the premium model, the model that is going to predict the amount of premium that we should charge, right? So, for instance, you gave it all the data it needs, and let's say the premium came out to be $500, right? So, for the model to come up with the $500, which feature impacted it the most is what you're trying to find with the feature important analysis. So, in order to help you with this, we're going to be introducing you to explainability tools like Sharp and Lime. So Sharp is more of a global, and Lime is more of a local interpreter or explainability tools to interpret the model's prediction. So this will help you understand how individual features influence the outcome. So which feature influenced the model to predict this, to have a certain prediction or outcome. So this is very interesting. Like it's like going into the brain of the model. Basically, we're going to be like getting into the brain of the model to see which feature made it decide a certain way or behave in a certain way. So this is really interesting. So this will help you understand black box models a lot more, and white box models as well. And of course, you will report a comparison of each model's performance. Okay, so the minimal instruction to do is to merge previous branches and create a new one, commit your work, prepare your data, build the model, evaluate the model, do rigorous model evaluation, selection, compare the model with appropriate matrices. Of course, some matrices could not be applied to other models, so you should select the appropriate matrix. And of course, the last is model interpretability. So, which is really interesting. And from this, you will identify 5 to 10 most influential features of your best performing. So before we finish up, so how is it? Like, is it clear so far on the tasks? What needs to be done? So is it clear? Okay, Deborah said it's clear. What about the rest? Is it clear? Okay, David just hit. How do we identify feature element to test? How do we choose the groups from grouping features? So we have already provided you with the hypothesis, like the hypothesis is that you're going to be testing, and depending on like the hypothesis, for example, for the gender, you can just see which are like which features are important to see if the total claim is different across gender, right? So you have the total claim and you have the gender. And for like the others as well, for the provenance, you will see you can see which features are important for that as well. So the features that you need to test or to group are driven by the hypothesis, the question that you are trying to answer, the region. So is that clear? If we choose zip code as feature to test, which zip code you want to choose. So all of them, if you are trying to if you are trying to compare them or see if there is a difference between zip codes, of course you have to use all of them as a control. Okay. Um, so any other questions, guys? I think they're just typing, but in the meantime, are there any questions? Anything that's not clear? Okay. So, of course, for the submissions, you will have two final and two interim submissions, each for GitHub and interim report. So, for interim submission, which is going to be Sunday, December the 7th, you're going to be submitting your GitHub link, which you have worked on for task 1 and task 2, and your interim report is going to cover task 1. Task 2 summarize your EDA finding and your DVC setup. And for the final submission, which is going to be Tuesday, December the 9th, you're going to be submitting the GitHub link, which has the complete work and a polished final report format in the format of a blog. This should be like self-contained and professional artifacts, a brief non-technical overview about the project for leadership, a clear description on your analytical approach, the most important insights from UDA, hypothesis testing and modeling, concrete data backed suggestion with AC, ISS marketing and pricing strategy, acknowledgement of data modeling, data or modeling limitations and suggestions for the future work. Of course, for the tutorial sessions, of course, we just had we are having the challenge introduction right now, and in the afternoon we'll have introduction to insurance analytics, and tomorrow we'll have a session on statistical distribution, hypothesis testing, and creating actionable insights. And in the afternoon we will have DVC, and on Friday we'll have a session on statistical modeling and evaluation, and in the afternoon we'll have introduction modeling interpretability. So and we will also have two Q&A sessions. Okay, so that's it from my side. They just said I see that field trees have genders. The rest is unspecified, or how the fold is weird. So it doesn't have to be specified. So of course you will have different coordinates, right? So you're trying to see, so if you are trying to see if there is a difference between two probalances, of course you have to specify those two probalances. But if you are trying to see if there is like a change or a significant change across all probalances, you can just have that as well. But if you want, you can specify based on your analysis. You can specify the probalances, you can specify the zip codes and so on. Okay. Okay, so any other questions, guys? Any reflections? Please ask. I would like to hear more from you guys. So any questions? How do you guys feel about this? Is there anyone from insurance background? Maybe here. any questions? So, Rishi, is it clear? Is everything clear from you guys? For you guys? Okay, good, good. Okay, good. So, if that's the case, I think we can wrap up the session. If you have any concerns, questions, or if anything's not clear, if you are stuck, please don't hesitate to reach out to me on Slack or by email. I will be there to help. Okay, if there is no questions, I think we can end the session here. Thank you everyone for joining. And just have the session presentation. And thank you, Daraja, for the questions. And thank you everyone for joining. See you guys on Slack, and have a good day.